This tutorial shows you how to print and prepare the LEGO road chain system. If you haven't already, watch the introduction video first. Printing and preparing the road plates.
The road plates are printed with dark grey PLA on standard slicer settings. You will need a build volume of 192 by 192 millimeters. For each road plate, you will need 8 LEGO 2x2 plates. These 2x2 plates need to be glued onto the base and surface halves of each road plate. The easiest way to make sure they align perfectly is to first make a sandwich of 3 plates. This also makes handling the plates easier. You can use any glue that works on plastic, but I prefer thick CA glue because of the curing time. Remember to always test fit the plates first, and don't overdo it. You only need a very small drop of glue to fix them in place. The plates with LEGO look also have side notches like the original LEGO road plates. If you want to use them, you should glue a LEGO 1x4 plate onto each notch placeholder. For each type of plate, I've provided a printable paint stencil for the road markings. Align the surface plate with the notches on the stencil, spray on a thin layer of matte white paint, and let it dry.
Printing and preparing the chain.
The chain is designed so it can be printed with regular PLA on standard settings, but I recommend to print it as fine as possible. This way it will be stronger and will run smoother. After printing, assemble the chain pieces by snapping them together. To split the chain, just hold 2 links at an angle and apply some force. The magnets you need to get for the chain can be up to 2 mm thick and max 5 by 5 mm in width. When gluing multiple magnets to the chain, be sure to check the polarity so that they all are oriented the same way. If you want to move bikes, scooters, or skateboards, you should glue 2 magnets next to each other and use one of the 2-wheeler sleds provided.
Preparing your vehicles.
There is no right or wrong when choosing the size of magnet for your vehicle. The easiest option is to use the same ones as your chain. The rule is simple. The further away the magnet is from the road surface, the stronger it needs to be. But it shouldn't touch the road surface. In order to test this out, I've included magnet sleds in different thicknesses. A magnet sled should be glued to a LEGO plate with a magnet glued in the middle. I suggest you print and assemble several of these so you can quickly test what works best for a particular car by swapping the sled with a thicker or thinner one. The sled should be placed between the front wheels in the middle of the axis. To test if the magnet doesn't touch the road surface, you should be able to slide some thick coloring paper underneath it. If you want to move larger vehicles, you need a way to make them turn into a corner without friction. This can simply be achieved by wrapping the front tires with some household cellophane tape, no wider needed than the tire tread width. This technique can also improve cornering with smaller cars. I've also included 2-wheeler sleds to be used with a scooter, bike, and skateboard. The magnets on these tiny sleds should be about 1 mm thick. Remember to glue 2 magnets on the chain also. Be sure to check the polarity before gluing the magnet to your sled.
Printing and preparing the drive unit.
The servo gear and sprocket are printed with regular PLA on standard settings. You could also print them with a stronger material, but after a 5-hour endurance test and more than 30 hours of total running, there is no wear and tear whatsoever, so I don't see the need. The servo gear should fit on the round servo horn that comes with your servo. If it doesn't fit, or if it doesn't come with these tiny screws, you could just glue them together with some CA glue, but be sure the gear is placed exactly in the middle and does not wobble. Therefore, you should lightly sand the servo horn flat before attaching the gear. The servo you will need is a standard size, continuous servo. This type of servo is also known as a 360-degree servo. Links to all the stuff you need are in the description below the video. By far the easiest way to power your servo is to use a servo tester and a battery holder with 4 1.5-volt batteries, optionally with a switch in between. A rechargeable AA battery can power your layout for several hours. Although you can power tracks up to 3 meters with a regular 5-kilogram servo, for a few bucks more you can buy a 30-kilogram servo, which will offer a lot more power if you want to grow your track later on. In that case, you should also use a larger power supply and controller, ideally in the form of an Arduino setup. This is a simple setup that anyone can handle. The wiring diagram and the Arduino code sketch are included.
Building the track. The first time you build a track, it's best to start by laying out the base plates first. Snap them together with a 2x4 Lego plate. Put the 90 degrees turn sprockets in place and slide in the chain. When snapping the chain together, be sure to have an overlap of at least one chain link. A little bit of slack ensures that the chain can move freely. Put the drive sprocket in last, and do a little test drive to ensure everything runs smoothly before covering up with the surface pieces. If you want to extend or change your layout, just snap the plates and chain apart and reassemble them in a different way. The chain can stay inside the drive unit cassette. The track you are seeing here is about the smallest track possible, but depending on the power of your servo, the number of corners you are using, and the amount of cars you want running, you can go up to 6 meters in length. Check the description below for the link to download the 3D print files, and happy building!